Congruent figures. How can transformations be used to determine congruence? Well, we have to understand that congruence means that figures have the same size and the same shape. We use the symbol with an equal sign and a little curvature mark above it to mean is congruent to. Now, it's important to understand why we use that symbol. If it would have the same size and the same shape, a lot of people might think, why aren't we just using an equal sign? Well, because through transformations we use and move things to different places, that's going to allow us to say that it's not exactly the same, because if it was exactly the same, it would be in the exact same place. But since it's not in the exact same place, although it has the same size and same shape, we add that little curvature line up on top there, and that's going to mean is congruent to. So let's kind of go over some things that transformations can prove congruence, and there are three types of transformations that allow us to do that. The first is translations, reflections, and rotations. All three of these type of movements actually just move position, move orientation. They don't actually change the size or the shape, and because of that, they can prove that two figures are congruent. Well, let's continue our discussion of congruence and look at two figures and talk about congruent parts. We know that all figures are made up of angles and sides. Well, if the figures are congruent, then they will have matching angles and sides that are equal in measurement. So let's take a look at this quadrilateral here, ABCD, and we have another one over here, WXYZ, and we're going to talk about congruent parts. So this little corner here, A, if we were to relocate it and move it through transformations, would be congruent with angle W. Angle B would be congruent with angle X. Angle C would be congruent with angle Y. And angle D would be congruent with angle Z. Now, when we take a look at the sides, we talk about the sides themselves. We look at side AB, starting from A, going towards B, and we use this little bar on top to mean side, and we'd say that side AB is congruent to side WX. We can see that side BC is congruent to side XY. Side CD is the same as side WZ. They are congruent. Side DA is congruent to side ZW. And you'll notice that you could actually grab the numbers, or the variables from the listing of angles and just grabbing that. So we wanted AB, here's AB, WX. We wanted BC, here's XY, we'd go XY. And you try to go in that order. Okay, so let's take a look at what this is about congruent figures, and see how can we move figure ABCD to figure WXYZ. Now, there are many ways that we can do them. So let's kind of see if we can record them a little bit here. So let's try one where we take this green figure and let's see if we can line it up right over on top here. So 1, 2, 3, 4, 5, 6. So we're going to move it over 6 spaces to the right. And then after we do that, we can reflect it over the x-axis. Flip it over here. And when we do that, it'll land up right on top of the original figure. So let's write that down, what we have. So we'll start with number 1 here, because we're going to come up with 3 ways altogether. Start way over here. So we are going to translate 6 units to the right and then reflect over the x-axis. Now let's put down what that would be with algebraic notation. Okay, that means that we would start with xy, 6 units to the right would mean that we would do x plus 6 and then the y. And then our next step, reflect over the x-axis, xy then what we would do to reflect over that, it would be x negative y. These are our two steps that we would do in that first one. Let's try another one. Let's take this blue figure here, and this time, why don't we reflect to see if we can get the same orientation. So let's reflect first, and now we have the same orientation, and we can see that we can just move it over 1, 2, 3, 4, 5, 6. So this time we reflected over the x-axis and translate, and then after that we translated 6 units to the right. Okay. And what we're going to do is we're going to write this in our algebraic notation as well. So this green one here, what we're going to do is we're going to reflect first, so xy, x negative y, and then we're going to translate 6 units to the right in our algebraic representation, x plus 6, y. Now there's all kinds of different ways, so let's get a little bit creative with our last one here. We're just going to do 3, and we're going to get a little bit more creative. So what we want to do maybe is take this red one and let's do a rotation. Let's rotate 180 degrees around the origin. And so when we do that, it's going to orient it upside down like this. And it's going to put us right on top of it, right there. And I'm going to move our other colors off to the side here so that we can get some more room. Oops. Let me grab that green one that fell apart. Okay, so when we did a 180 degree rotation, we ended up right in the right spot that we wanted, but we noticed that we are upside down. So let's kind of start out with that and see where we go. So we want to do a 180 degree rotation, and we don't need to say what direction we're going, clockwise or counterclockwise, because whether we go clockwise or counterclockwise, we end up in the same place. But we're going to say that we're going to go 180 degree rotation about the origin, because that's going to be our center point for us. Now, what we're going to do next is we need to turn this on top of itself. We need to reflect it upside down. So what we're going to do then is we're going to grab a line, and we're going to make this our line of reflection. So let me get a line here. And let's pick a color, a nice color, purple here. And I'm going to draw a line right through the middle of it. So if we took this and we reflected it, what it would do is it would turn it, let's see, flip it, left to right. And we do that, and boom, we're right on top of it, exactly where we want it to be. So let's go back here. Now the question is, where is that? Because before we reflected over the x-axis. Well, now we're reflecting over a line. We need to remember what this line represents. This line here, if we were to write out what it is, this is an x equals line because it goes up and down. And since it's going through 3, 1, 2, 3, this is x equals 3. So we're going to finish our statement here. It's a 180 degree rotation about the origin and reflect over x equals 3. So that will get us to where we want to be. Now, how do we write that in notation? Well, we do know that we can write the 180 degree rotation this way. XY changes to negative x, negative y. But unfortunately, we don't have any standard notation for reflecting over x equals 3. So we're going to have to leave that right now in just words in the English language. So hopefully this explains a little bit about congruence and how we're going to move things around. And we can see that by moving them around, we did preserve the same size, we did preserve the same shape, we just moved it to a new location, and in this case, a different orientation. So we can use transformations, specifically translations, reflections, and rotations, to prove congruence.